Well, we have question 7 here. The question says a corner of a rectangle blocks of a corner of a rectangle block of wood is cut off and shown in the diagram below. The inclined plane that is the triangle ACD is an isosceles triangle having ADC, the angle ADC equal to ACD equal to theta. Also ACB, angle ACB equal to a half theta, and AC is equal to x minus 3, and CD equal to 2x. Now the question says 7.1 says determine an expression for the triangle, the angle CAD in terms of theta. All right, we can see that angle theta is over here, and the angle theta is there, and then we want the angle CAD. CAD is this CAD. So we're talking about this angle. Now on the right here, question 7.1. So the angle CAD is what we are looking for. What do we know by definition? We do know that sum of the angle within a triangle is equal to 180 degrees. So in this case, we have like, we're gonna say, we have like theta and theta. So we do theta plus CAD. This is equal to 180 degrees. The reason is that sum of the angle of the triangle, all right, like the sum of angles in triangle, abbreviate like that, and then theta plus theta makes 2 theta. If I move them over, that makes CAD equal to 180 degrees minus 2 theta. So all this makes 2 theta. 2 theta, okay? If you move over, we have like the angle CAD equal to 180 degrees minus 2 theta. That's the expression in terms of theta. All right, now the following question is question 7.2. The question says prove that cos theta equal to x over x plus 3. Okay, I'm gonna write the question over here, 7.2. So cos theta equal to x. Okay, I can see x is okay, I cannot see x over here, but I can see expression in terms of x. And then they say it is equal to cos theta equal to x over x plus 3. So we need to prove that cos theta equal to x over x plus 3. Now, when we see something like that, it means exactly cos theta is x over x plus 3, but we need to prove it, we need to show why it is so. Okay, in this situation, we can use we can use the cos formula, for instance. Okay, in the triangle, I'm referring to the triangle. Right. I'm going to look at these triangles over here. You can see I'm going to just write. I'm going to look at this triangle. This one, that one, and that one. Okay, the triangle ACD. So okay, we have like this side is given, it's x plus 3, and then the fact that the angle, okay, are the same theta here, that tells me that the triangle is isosceles triangle. Therefore, we can also say this side is also x plus 3, and then this side is also given, okay, to x. So we have like all the angles given, so we can apply the cos rule. Okay, I'm going to write here cos rule. Cos rule. And the cos rule says this: a squared, by definition, a squared equal to b squared plus c squared minus 2ab. No, minus 2bc times cos of a. Okay. So remember that. The angle A here will always be the angle opposite to the sides A. Okay, the length, because this a, the lowercase a here is the length. Okay, the side, and then the uppercase a over here is the angle opposite a. Now, in this situation, we need to express cos theta. So I'm going to look at angle theta. Okay, in this case, I have like two theta here. Doesn't matter which one I select. Let me see. I'm going to take D. Okay, so I'll say, okay, I'll say the side opposite D is the side AC. Okay, so I'm going to say over here, AC then, AC squared will be equal to, excuse me, AD squared, okay, plus DC squared, the other side squared, AD, okay, plus DC minus 2AC, minus 2 AD times DC minus 2 minus cos of, excuse me, minus 2 AD times DC times cos of theta. Okay, now we can express AC. AC is like x plus 3 to the power of 2, and then AD is the same as AC because the same angles implies that these sides are also equal. So this is x plus 3 to the power of 2, and then plus DC is just 2x squared, and then minus 2 AC is x plus 3 times 2x. Okay, I'm going to move my body a little bit this way, times cos of theta. Okay, if we, okay, we can see now, we can simplify. Okay, you see, they are equal, so I can cross this and that, because if I move it over, it's going to be the same quantity on the other side. It's going to be they can cancel out. And if I move the 2x to the power of 2 over, so we have like 2x to the power of 2, like that, equal to, we can simplify this. This is like, if I do 2 times 2x, that makes 4x, times x plus 3, cos of theta. I think I want to move, I have to move my board this way. Now we have 2x to the power of 2 will be like 4x squared equal to 4x, x plus 3 times cos theta. So I would like to write my unknown on the left hand side. So I prefer to, okay, so we have like 4x times x plus 3. Okay, I interchange the sides equal to 4x squared. I need to find cos theta. I'll keep cos theta on the left and then divide everything by 4x, x plus 3, all under 4x squared. Okay, so I divide this part by 4x, x plus 3. I divide it also by 4x, x plus 3. Now, and then we have like cos theta equal to 4x squared over 4x plus open bracket x plus 3. Now we can simplify further. We can cross out, simplify 4 and 4. Okay, x squared with x, and then we have left with cos theta equal to x over x plus 3. This is exactly this expression over here, proven. So this is proven. Okay, we can also prove the same calculations. We can prove the same, that this expression is correct by using also the sine formula, because we have like angles given here and sides, so we can also use the sine formula. When I set here the sine rule, when I split my board like this. Okay, we can also say use the sine rule, or say sine rule. The sine rule is given by sine theta. Okay, let's first draw the same diagram over here. The same diagram over here. So this is the diagram. We can also use the sine rule. Okay. The sine rule is given by okay, sine of A over A equal to sine of B over B equal to sine of C over the lowercase c. Over here, sorry, I meant to write lowercase because the lowercase by convention, the lowercase stands for straight lines. Lines, yes. Not, but uppercase will be angles. So these are lines like A, and then that B and that C. So this simply means that sine of the angle theta over here will be, I'm gonna write then, sine theta will be over the side opposite theta, okay? Because we did find that these two, this side is also x plus 3, because we have an isosceles triangle here. They both theta, okay? So we can now then say sine of theta over x plus 3, okay? Will be equal to, over here also, if I do this side, this angle, I'm gonna get also sine theta equal to over x plus 3, but I don't want to do that because it's the same value. So I'm gonna take this other angle we worked out previously. This angle is 180 degrees minus 2 theta. So I'm gonna say this is equal to sine of 180 degrees minus 2 theta over 2x, okay? Now, you can also, listen, you can also do, you can also write the formula like this. Sine A equal to, B sine B equal to C over sine C. So it's still correct, okay? We're gonna get the same answer at the end. Now, let's move the board like this. Okay, because of space, I'm gonna take this out. So now what we have, that makes sine theta over x plus 3 equal to sine theta, sine of 180 minus 2 theta. This is equivalent to, okay, you know, sine, if I use the sine formula, for instance, I'm gonna draw a diagram here. We do know that sine is positive in the first and the second quadrants, okay? So we can reduce sine 180 degrees minus 2 theta to sine of 2 theta, okay? Over 2x. Then we can write sine of theta over x plus 3, and then sine of 2 theta by definition. We do know that sine of 2 theta is, you know, sine of, I'm gonna write the definition, the formula over here. Sine, oh la la, I think, let me write it over here. Sine of 2a, this is equal to 2 sine a cos a, okay? So sine of 2 theta can be written as 2 sine theta cos theta all over 2x. Then I'd like to introduce something. When you have an equation like this involving fractions, you are allowed, okay, it is allowed to cross sine theta like this and sine theta like that, okay? Regardless of the manipulation you will do, you will end up simplifying sine theta and sine theta there. Okay, you can do that only when you have an equation. By that I mean an equality between the fractions, okay? A fraction on the left equals sine, fraction on the right, you can cross out products, okay, that are similar. You can simplify that way, and then this means you have left with 1 over x plus 3 equal to cos theta over 2x. Okay? This 2 there. Oh, okay, let's also simplify these 2. We can also simplify 2 here and 2 there. We can simplify like that. And then we're left with that. Now, we can cross multiply. So we can cross multiply. We can do that, this times that times that. So we have like, then x plus 3 times cos theta, okay, equal to 1 times x. Okay, we can divide them both sides by x plus 3, and then divide by x plus 3 there, and then we have left with cos theta equal to 1 times x just x over x plus 3, because this was cancelled. Now, this is again proven. Thank you.